Example 1. During the contact process, SO2 is converted into SO3 in a reversible reaction below. The equilibrium was established at 1000 Kelvin and a small sample of the equilibrium mixture extracted. It was found to contain 1 moles per decimeter cube of SO2, 0.2 moles per decimeter cube of oxygen, and 1.4 moles per decimeter cube of SO3. Calculate the Kc and Kp at this temperature. So first step, okay, write down the balance equation, right? So we are going to write down again the balance equation, okay, and then construct the reaction table. Since here, okay, we have the concentration of each species, so we are going to use the reaction table in terms of concentration first, okay. So we have the initial concentration in molar, concentration change also in molar, and last but not least, the concentration at equilibrium also in molar. Right, so we already have our reaction table, and then have a look at the information given. The concentration given here is the concentration that is found at equilibrium. Okay, because it states here a small sample of the equilibrium mixture extracted, it was found to contain blah 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 blah. So this information here is at equilibrium. Okay, so we have 0.2 molar and also 1.4 molar. So mole per decimeter cube is also molar. Alright, and then we need the Kc expression. Okay, the Kc expression is equals to the concentration of SO3 to the power of 2 divided by concentration of SO2 to the power of 2 and concentration of oxygen to the power of 1, because here we got 1 mole. Alright, and then K here means the equilibrium constant and C is in terms of concentration. So the concentration in this expression must be the concentration at equilibrium. So the concentration at equilibrium is this. Alright, so substitute the value. We have 1.4 molar to the power of 2 divided by 1.0 molar to the power of 2 and 0.2 molar to the power of 1. And press your calculator, you will get 9.8. Since we already have the value of the Kc just now, okay, to calculate the value of the Kp, we are going to use this formula. Kp is equals to Kc RT to the power of delta N. The number of mole, the change in number of mole here is refers to the number of mole of the product gas minus with the number of moles of reactants gas. Okay, just focus on the stoichiometric coefficient in the balance equation. So since here, okay, we have 2 moles of the SO3 gas product. Okay, so the delta N in this reaction is 2 moles of the SO3 product minus with 2 moles of SO2 gas product reactants plus with 1 moles of the O2 gas reactants. Okay, so 2 plus 1 here is equals to 3. Right, so 2 minus 3 is equals to negative 1. So the formula that we are going to use here is Kp is equals to Kc times Rt to the power of minus 1. So substitute the value. Okay, we have 9.8 of the Kc. Okay, R is 0.08206. Okay, the temperature here must be in Kelvin. So we have 1000 Kelvin just now. Okay, and then to the power of minus 1. And then press your calculator. 9.8 times, open the bracket, 0.08206 times 1000, close the bracket, and then press this and then insert minus 1. Right? You will get the answer 0.1194.